right, today we start working with solving both exponential and log equations, and what's going to be critical here is properties. Okay, and I'm not going to review all of those, but you're going to have to sometimes maybe have your properties close by when you're doing this assignment. Otherwise, you might get a little frustrated at times. So, let's get rolling with our first problem. Let's say that I have e to the x equals 72. Okay, this is a new situation. We haven't seen this before. What am I going to do? Well, I need to remember a property. There's a property that says the natural log of e to the x equals x. So this is an equation. So long as I do the same thing to both sides of the equation, it's okay. So what we're going to do is we are going to take the natural log of both sides. That is a legal step, legal algebra step, to take the natural log of both sides. Now look how easy this is. What's the natural log of e to the x? X, right? This problem is done. X equals the natural log of 72. The natural log of 72 is just a decimal. Of course, you can use your calculator and find out what that is. I'll just do it real quick. The natural log of 72 is 4.28. All right? So, you know, there are some problems tonight that will be pretty easy like that. Let's keep going. Maybe you see something like this. E to the 2t minus 1 equals 5. We're going to do the same thing. It's going to work out a little bit differently. It's going to be a little bit longer. But we're going to take the natural log of both sides. Okay? And the reason we do that is because on the left side, the natural log of e to a mess is just this mess. So this is just the same thing as 2t minus 1. That equals the natural log of 5. Now, all you have to do here, maybe to keep your brain from, frying, is go ahead and figure out what the natural log of 5 is. All right? So if you do the natural log of 5, you find out that it's 1.61. All right? And now it's just a regular algebra equation, right? And so I would add 1, 2t equals 2.61, divide both sides by 2, and you get 1.305 approximately. Okay? So that's one method you have on those last two problems. How about this one? If you see one like this, you're thrilled to death. You know why? Because e to the natural log of a mess is just the mess. That's another property we learned. This is just 2t minus 1. All right? The property says e to the natural log of a mess is just the mess. So now isn't it just basic algebra? Okay, I don't need to finish this one. Let's go to the next problem. How about this one? 2 to the x equals 10. Now, if it were me, I think the easiest way to do this problem, there's no property for this problem the way it sits right now. So what I want to do is take the natural log of both sides. Why would I do that? Because there's another property that says that the log or the natural log of a number to a power, I can bring this power out in front. All right? And so now I have x times the natural log of 2 equals the natural log of 10. And I know that looks kind of strange and quirky, but these two things right here are just numbers. They're just numbers, all right? So what I would do is divide both sides by the natural log of 2. Divide this side by the natural log of 2. These are just numbers, just like a regular algebra equation. So you get that x equals whatever the natural log of 10 is divided by whatever the natural log of 2 is. It's going to be some kind of decimal answer. Okay? I'm not going to take the time to plug that in. It's pretty easy. All right, let's keep moving here. How about this one? Five plus the natural log of x equals 4. Well, you know, this is still algebra, so let's try to get this thing kind of isolated a little bit. Subtract 5 from both sides so that I have the natural log of x equals -1. Right? Now, to finish this, what I would do is I would say that this is log base e of x equals -1. Does everybody see how to finish it? The switcheroo. E to the -1 equals x. Or I could just say that x equals 1 over e. It's totally okay because e is just a number. All right, that would be some kind of decimal answer. All right. Lots of different situations, okay? I'm trying to expose you to a lot of these different situations. How about this one? Let's see, that was example 4. Here's example 5. This one looks a little different, but you know, think algebra. This is 3 times this. So why not divide both sides by 3 first? So now you have 2 to the x equals 14, right? Now isn't this exactly like the one we did a couple problems ago from this point on? Now it is just like this problem, right? So I'll say finish like number 4. I guess I got off on my numbers, didn't I? This was actually 5. This was actually 6. So finish like 4. Okay? Same type of deal. Example number 7. How about, you know, this might look scary, but it's really not that bad. Something like that. Well, you know, let's do some algebra and make this thing look a little bit cleaner first. Let's add 4. So I have 15 equals 8 times 2 to the 4x minus 1. And why don't we go ahead and divide both sides by 8? Which is going to give me 2 to the 4x minus 1 equals whatever 15/8 is. 15/8 is 1.875. Now, maybe you can tell me what we should do next. What should we do next? I'll give you a hint. You've seen it before. Saw it on number 4. I would do it like number 4 from this point on. I would take the natural log of both sides now. Why would I do that? Because I can bring this power around in front. That's why I would do it. All right? So now I have 4x minus 1, that whole quantity times the natural log of 2 equals the natural log of 1.875. And then I can, divide by this natural log of 2 to get this thing looking more like a normal algebra equation. So the natural log of 1.875 divided by the natural log of 2 is 0.907. So now I have 0.907 over here, and on the left side I just have 4x minus 1. And now isn't it just a normal algebra equation from this point on? Okay, I'm not going to finish that one. I want to get to one more. At least one more, maybe two more. See, this is example 8. Solve using the TI-84. Eight e to the 2 minus x equals 30. What would I do? Well, here's what I would do first, is I would go ahead and divide both sides by 8. So I have e to the 2 minus x equals whatever 30 divided by 8 is, 3.75. Now, just so you understand our thinking, what we're going to do is we are going to graph this, okay? And we're going to look for where it is equal to this. All right? Now, we've done this year, all right? So let's go to the graphing calculator. And I apologize if the screen is a little bit cut off here, but I think most of you probably know what's going on by now with the keystrokes. So the first thing we want to do is put in the function. So our function that we had, we need to go back to our equation. It was e to the 2 minus x. So I'm going to put in e to the 2 minus x. Okay? Now, we may as well save ourselves some time. I'm wanting to know when it was equal to 3.75. So we may as well go ahead and graph y equals 3.75. Graph them both. And maybe we'll just do a standard window. We'll go zoom standard. So there's the exponential function, and there's 3.75. Now let's close down our window a little bit. Maybe we'll go -2 to 5 and -1 to 6 or something like that, just so we can see it a little bit better. So there's my exponential function, and there's my y equals 3.75. All we have to do now is calculate an intersection. So I go to second trace and calculate an intersection, number 5. And our first curve is already labeled, but we need to move it up. Sorry about that. Let's move it up to our point of intersection, or at least close. Hit enter. Our second curve is y equals 3.75. My cursor's already there. Hit enter again. And hit enter one more time. And the point of intersection is x equals 0.678. So, again, my answer was x equals 0.678, but we found that by graphing e to the 2 minus x, okay? There's e to the 2 minus x. And by graphing y equals 3.75 and looking for that point of intersection. So that point of intersection corresponded to an x value of 0.678. Okay? And we are going to stop there for today.